Today we're going to be talking about condensing logarithms into a single expression. And so to be able to do these, we need to go with the properties, and these properties tie back into exponential. What you have to remember is each time you have a log, that is an exponent. So when we had our bases, our total numbers being multiplied, we added our exponents. When we divided, we subtracted our exponents. When you rose a power to a power, you multiplied your exponents. Anytime you wrote something to the, and you got the 1 as an answer, that meant that it was 0. And I'll go ahead and go over show you these here in a little bit. But let's go ahead and go through the first set. So what this looks like, if I did a number, if I had log base 3 of 5 plus log base 3 of 7, my answer would be log base 3 of 35. So let's go through another one. If I did the division, I have log base 7 of 15 minus log base 7 of 3, then my answer is log base 7 of 5, because 15 divided by 3 is 5. Now, one thing to note, on both of these, notice how in the problem my base was consistent. That has to be the same number through all the bases. The base could be your common log, which is just written like this. Log of 10 is understood to be 5 plus log of 10 of 7. That would give us log of 35. So those all work the same. Typically, you try to put parentheses around what happens after your log just to keep things looking nice. Another thing people will sometimes do is they'll write it in cursive. I typically don't write my log in cursive, but I do anytime I'm using LN, write it in cursive. That way it doesn't look like a 1. So the next one we had was this power. So I'll show you how that would look. So if I had 5 log base 3 of x, that's the same thing as log base 3 of x to the 5th. Now let me go over the last set. These are just kind of more, they're properties, but they come through based upon, especially these two, based just on the conversion. So if I had log base b of 1 equals 0, remember if that was an exponential, that meant b to the 0 power equals 1. This is your exponential property. And then the same thing here, log base b of b equals 1. If I convert that over to the exponential, that'd be b to the first is equal to b. Or 5 to the first is equal to 5. Or 15 to the 0 is equal to 1. So these two just come from just looking at the conversions. You should have been able to discover at least this first one in the assignment from yesterday. Now this next one, it again comes from kind of looking at the properties we had above and this property. And so if I have log base b of, let me just put numbers in this because it seems to make things easier on these if I do have numbers. Log base 5 of 5 to the 2nd power is equal to 2. If I was to convert this, that means my base to my exponent equals my solution. So 5 to the 2nd is equal to 5 squared. Again, just kind of looking at how that converts, and that gives us that property. But all you need to remember is if these two numbers match, that cancels out the log and just leaves you the exponent. Let's do the same thing for this next one. Let's look at how it would be if I converted b to the log base b. Oh, again, let's put numbers in this. Let's use 8 to the log base 8 of 7. And that's going to equal 7. So let's convert it. So we're an exponential. I need to go to logarithmic to convert it. So when I convert it, I have log base 8 of my answer 7 is equal to my exponent, which was that log base 8 and 7. So again, if those match, they cancel, leaving just that k. Let's go ahead and work a couple of problems. Let's look at this first one. And so my big operation that I'm looking at is subtraction. So when I look at those rules, the rule that had to do with subtraction told me that I would divide. So that means that I have log base 4, and we're going to take these two numbers and divide. 32 divided by 2. And that gives me log base 4. 32 divided by 2 is 16. That's my answer. Let's go on to the next one. So we have a couple of things going on in this one. We have our coefficients, and we have our addition. So let's look and see what properties we can use. So for the addition, that property tells me that I am going to end up multiplying. And for the coefficients, that is the one that tells me that's going to become the exponent. So I always take care of the coefficients first. So I'm going to take that 6 and I'll move it to the exponent. Same thing with the 5. I'm moving it to the exponent. So log base 2 of x to the 6th power plus log base 2 of y to the 5th. And putting those in parentheses so I know for certain what's in my, when I'm taking the log of. Now I'm going to take care of that addition. Now, to be able to combine these two, I need to also look to see, are these bases the same? They are. So log base 2, and with addition, that tells me I'm going to multiply x to the 6th times y to the 5th. That's my answer. So we are going to take and look at the properties. Again, it's very similar to the last one. I have the coefficients that are going to become my exponent. And then I have addition that's going to become multiplication. So when I take and move that exponent up, I end up with log base 3 of x to the 1/2 plus log base 3 of y to the 1/2. Next thing we need to do is 1/2 is not one of the things you leave as an exponent. We need to take and simplify that. When you have something to the 1/2 power, that's the same thing as taking the square root of that item. Now, our bases match. So that means I can write this as a single log. And since I have addition, that means I'm going to multiply those. And so I have the square root of x times the square root of y And that's not the best way to write this. Since these are both square roots, that means I can multiply what is under my radical together. So I want to end up multiplying the x and the y and leave it under that radical because the radical matches. So log base 3 of the square root of x times y. That's my final answer. So in this one, we have multiple things going on here. I'm using the LN, that means there is no, that's understood base of E, but we just abbreviate it with LN. And so looking at what we have addition, we have a division, which is, or subtraction, which is going to become that division. Let's go ahead and pull that out so we can kind of look at the properties. So the subtraction, that's going to become division when we work it. And when we had addition, that came multiplication. We also have a coefficient that's going to become our exponent. So I'm going to take again, always start with your exponent first. And so ln of x plus ln of y squared, that 2 coming up, minus ln of z. So I'm going to take care of my addition next. Ln of x, y squared minus ln of z. Now subtraction becomes division. Ln, and I'm going to have the x and the y squared in the numerator and my z in the denominator. You could have done this all in one step and jumped down to here. Just remember, anything that had a minus sign in front of it, it's going to go in your denominator. Anything with the addition sign in front of it, it's going to be a part of your numerator. So let's do one more of those type before I let you work on one on your own. So again, let's look and see what properties do we have and which one do they go with. So I had that 2 and the 1/2. They're coming down here and becoming our exponents, where that 1/2 is going to become a square root. I have my multiplication, the addition that's going to become the multiplication, and I have my subtraction that's going to become a division. So go ahead and moving things around. I'm going to go ahead first remember exponents. So log base 10 of x squared plus log base 10 of y. And the reason I don't have to write the 10 is it's understood as the common log. Log base 10 of z to the 1/2 power. So I'm going to rewrite that log base, that z to the 1/2 power, as the square root of z. Now I'm just going to do the shortcut version. So anything with addition is going to be my numerator. So log base 10. It's a little better so it can go here. Of x squared y divided by the square root of z. The addition went in the numerator. The subtraction goes in the denominator. I want you to work on one on your own. And just so you have the rules here. And one thing I really didn't emphasize earlier was this note down here. All of these are b has to be greater than 1, and we have to have positive numbers for m and n. You should have found that log base 4 of 15x squared, because you multiplied those two together.